regarding number system. Before I would start, I would like to know what do you know about number systems. Means, do you know about anything about number line, or we write numbers on that line? So you must have heard about it. Okay. So in that fashion, in the forward, going from that, we are here to learn more concepts regarding number system. Okay. So number line you must be knowing so far, if you can remember. This is a line. Okay, this is a line, and this line has a middle point, and this is called zero. Means it's a zero. You must be aware of. And in this number line, from this is left side, this is right side of it. Okay, so on left side we write minus negative numbers. Okay, so and on right side we write positive numbers. Okay, so on left side, if you go from 0 to on right side, so it will be like 1, 2, 3, 4, 5, 6, and if you go similarly and so on. Okay, it will not stop at 6. And if you go like on left side of 0, we will write -1, -2, -3, -4, and so on. Okay. One more thing you must have learned, that these numbers are equidistant from each other. Okay. So equidistance means the distance between 0 and 1, and 1 and 2, 2 and 3 are same. Okay, the distance is same, and same goes from this side. Okay, you must have read this much in your previous classes. So in this class, in 9th class, we will talk more about numbers, how many types of numbers you have, like why the mathematicians or the people who invented or discovered this number system, what need they must have felt. Means why did they started creating these numbers. We must be curious of these things, right? We know about counting numbers to count. Okay, so we use natural numbers. There are types of numbers. So different kind of numbers are just set of numbers, right? There are different type of set which we give some names, and these are called numbers. Different sets have different utilities, so that's why. Okay, first come is natural number. Okay, let me jot them down one by one or at once, and then we will go forward. So as far as your class is concerned, 9th class, there are these types of numbers, like 5-6 types of numbers which you must learn. Okay, and these numbers of course come in practice or in uses in your class, or of course in future in your career or life. But understanding these, at least these types of numbers, will help you a lot. Okay, now we will go one by one. This is set of natural numbers. Okay, set of natural numbers are denoted by, how we denote them? We denote by the n. Okay, this is a capital N. So that means numbers from 1, 2, 3, 4, 5, yeah, and up to infinity. Infinity must be, maybe you are aware or not, but yeah, infinity means to an extent that we cannot even count. That's called infinity. So here you can clearly see these numbers we usually use in counting. Let's say if I have to count how many students in this class. Okay, so I would say 1, 2, 3, and so on. So second set is called whole number. Whole number is nothing but a set which include natural number plus 0. If you include 0 in the set, it's called set of whole numbers. Whole numbers means this 0 completes this set. And what about integers? These are numbers, okay, right? But what if can we use, or can we make some operations between these numbers? Of course we can. 1 plus 2 is 3, which is available here, and 2 plus 3 is 5, and so on. But what if we do some subtractions, like 2 minus 3? What will be 2 minus 3? 2 minus 3 will be -1, right? But -1 is not in this set. So that set, which include negative numbers also of these positives, is called set of where I can say 0, 1, 2, 3, 4, 3, and then on the side -1, -2, -3, -3, and -3. The fourth types of number is rational number. Rational numbers are denoted by Q. Q means quotient of numbers which can be expressed in P by Q form, where P by Q form, okay, where Q is not equal to 0. P and Q are integers. Firstly, are integers, okay, integers, right? All those numbers which can be expressed as P by Q, P and Q are integers, okay, and Q does not equal to 0. So these type of numbers are called rational numbers. What will happen if Q is 0? So let's say P by Q is 0. What will happen? It is generally called a undefined number. Okay, this is not a defined one, or we usually say it's infinity value. Okay, it holds infinity, or it is equal to infinity, but infinity has no meaning, has no practical meaning for us, so that's why we say it's a not defined one, undefined. Okay, undefined. That's about this under root 2, square root of 2. What kind of number is this? Can we express this as p by q, or is this number belongs to any one of these sets? Of course not. Why? How we are saying, if we know about if we calculate the value of square root of 2, it is like it will come around non-terminating, non-recurring expansion of decimal it has. That's why we say it's irrational numbers. Okay, so such numbers whose decimal expansion is non-terminating and non-recurring are called irrational numbers, or we can also say in one sense that those numbers who are not rationals, who does not belong to this category, are irrational numbers simply. Okay, and yeah, so in this fashion the number line. Okay, so real number line is nothing but this line. Okay, 0 to 1 is a number line because it's real number line because we represent real numbers on this line. That's why we call it real number line. Okay, so let's say 1, 2, this, and same here. In between these numbers there are of course many other numbers. Okay, -1, -2, -3, -4. Okay, so between these numbers there are many irrational numbers, so we also include them. And same here, same for every between every set of pair of integers. Okay, they are rational or irrational. All the numbers when put together form a bigger set, that's called set of real numbers. Okay, so these are types of numbers. Okay, which you of course need to learn, and sometimes I would say have to memorize, but firstly you need to understand them. So what's the difference between one set and another? And yeah, and what if I say set of rational numbers and set of irrational numbers are very important for you to understand. And now we have to find, let's say, 10 rational numbers. Between them we want to find 10 rational numbers. How will you do that? There are two methods, of course both have same. How do we know this is smaller and this is bigger? Because you must have learned so far that if there are two numbers and both have same numerator, and the number whose denominator is bigger will be lesser than the number whose denominator is lesser, right? So we can say this is bigger. We must have read this much, okay, so far. So now we will get a difference of them. Okay, we will find difference of these two. It will be like how much if we know how to subtract two numbers. You must we will get this one 6 as a like SCF or also LCM, and then we divide and we get 3 here and 2 here, so 1 by 6. We want 10 rational numbers. Okay, numbers between 1 by 2 and 1 by 3. How will we do this? We will take difference of these numbers, and whatever difference we will get, we will divide by 10 plus 1. 10 plus 1 will be like 10 plus 1 will be 11. We will divide it by 1 by 11. Okay, so it will be like this will be like this one. Okay, now we will add this 1 by 1 by 2, 1 by 3. That's 1 by 6. So it will be like 23 upon 66. And again then we will add it here 24 by 26. 66 times. Same we can do rest of the process. So if I write all the numbers at one place, 24, 25. So these are 10 rational numbers between 1 and 1 by 2 and 1 by 3. And then we get, no actually you will do some adjustment. First we find this gain and export. There LCM 1, 2 and 3 equal to 6. And now you have to find how many numbers? 10 numbers, 10 numbers in these two. So you will divide, you will multiply 6 by 11, 66. Now you will do 11. Okay, and same thing here. 66. Okay, now you will do divide by 2, so it's 33. Divide by 2 is 22. So you have to now write numbers from between this. Now you can write these two very easily. So this of course same result will follow. Okay, in this way we can write numbers between two given rational numbers. Okay, so of course we can write even 100 rational numbers between these two numbers, 100, even 1000, even millions, as much you want. Okay, so we can say there are infinitely many rational numbers between two given rational numbers. So I jump to irrational numbers. There are other types of numbers also, that's called means in rational numbers there is a category of numbers. These are called equivalent rational. So this is the reduced form of these two numbers, right? So when P and Q are co-prime with each other, then this rational numbers in its reduced form. Okay. Now we talk about irrational numbers. Okay. So are there any other numbers who are called irrational numbers? Of course there are. You must have heard about pi, irrational number, and like it's called E. It's an exponential with 1. 3. Square root of any prime number is also an irrational number, and of course combination of these numbers, these prime numbers, also generates some other types of irrational numbers. So what do you think? How would the mathematicians have landed there? Means how did they come up with these types of numbers? Okay, such kind of number also exist. I'm saying you there exists another class of numbers which is called irrational numbers. But how do we know or how do we express them on real lines? Yeah, it is easy to express 0.5 on real line. How? It's a 0 and it's a 1. So just divide this distance by 2. We will get 0.5. So it's an easy task. Let's understand about them a bit. Okay. So this is a distance from this to this. Here we will use Pythagoras theorem. There is a triangle, right angle triangle. Okay. And this is like a perpendicular, this is base, and this is hypotenuse. Okay, so hypotenuse square is equal to perpendicular square plus base square. So this is a theorem. This is called Pythagoras theorem. If it is distance of one unit, okay, and what I do, I make a perpendicular side of unit 1. Okay, right. So what I get, and if I connect these two, I get a right angle triangle. Okay, so this right angle triangle, this is unit 1, this is unit 1. This is perpendicular, this is base. So what will be the hypotenuse? It will be of course under root 2 from this formula. 1 square plus 1 square equal to 2. Hypotenuse square equal to 2, so it means hypotenuse equal to under root of 2. Inside this under root 2. Okay. So this distance is under root 2. Now what if I draw a circle? Okay, or I would say a arc of a circle which curves. Let's say the circle has radius this. This is the radius of that circle. So if I draw a circle using this as a radius, what I get? This much. It cuts, this arc cut the line at this point, right? So, and we know radius of a circle are same, radii of a circle are same, of same length. So it also be of length under root 2, this much. Okay, under root 2. So in this way I can say this point denotes under root 2 on the number line. So this is how we locate a number, okay, on real line. And we can similarly represent this one. It will be a bit not an easy task. Why? There are two reasons. Because we don't know exactly the numeric representation of this, number. Same for this. These are sometimes called, I think, transcendental numbers, but yeah, but still they are in the category of irrational numbers. But as far as representing these numbers on real line, we can oppose to using this process. Okay, and there is other method also, which is where we denote some irrational number. For that's also an irrational number category of irrational numbers, where the inner number is not an integer. It's a fraction of, let's say 3.1 is some number. Okay, and now we have to denote this where this number will exist on real line. This other method, can we use same method to represent this? I doubt, because there we are using a Pythagoras theorem. Okay, so it's a not it doesn't look that feasible as it look for these integers. Rationalization of denominator. If let's say root 2, in this case there is some minor difference which we need to practice or use. That's when there is a number. Okay, it's a rational number, of course. If you have to multiply by something so that its denominator get rationalized, we multiply it by, say, conjugate. There is actually identity. Okay, algebraic identity. I'll tell you about that later. Just give me a moment. Okay, so even if we do here, it will be like this: 1 square is 1, and minus is minus, and under root 2 square is 2. So it will be like, it will be minus 1. Okay, and it will be like minus under root 2 minus 1. So this is a rationalized when this is a form when we rationalize its denominator. Now I have used here one algebraic identity. Okay, this is algebraic identity which you will learn in your latest chapters. Okay, so this is what there. Okay, so this was an overview, or you can say a quick go through of the chapter number system. I hope it was beneficial to you. Let me know if you have any doubts related to any part I have taught here, and you can tell me whatever you find suitable for you. Okay.